Okay, dear student, let's see what is there in this question now. The graph shows the variation of gravitational potential V with the distance r from the center of the planet of a radius capital R. Okay, so as I have already told you in my lecture classes that the gravitational potential, as a thumb rule, it is always negative. It can never have a positive value. So all the values will be negative and they will start from the surface of the planet and they will move like this because there is an the hyperbolic variation there. Yeah, so a mass m is placed at r is equal to 3r. So this is the point where a mass m is placed on that point. What quantity when multiplied by m gives the gravitational potential energy of m due to the planet? Okay, so what energy it will be, like we have to find the potential energy due to the planet. So clearly we know that the formula for the potential energy is, or I would say that the formula for the potential is given as potential energy divided by the mass m. As I told you, it is per unit mass, isn't it? Like mass was supposed to be 1 kg, or you can say it is the total potential energy of the system per unit mass of the test mass, isn't it? So PE by m. So you want to find the potential energy, so mass has to be multiplied by the potential at that point. So if you talk about this 3r here, so it is like this. So this is the potential which is at that point 3r. So the potential energy will be m times v. So you find v here and you multiply with the m, so you would be finding the potential energy. I think that gives our answer. But let's go for the options now. So point number A is the gradient of the tangent at line r. Now gradient has no meaning here. Like if you're finding the gradient, E is given by negative dv by dr. So if you find the gradient at this 3r point, let's say at this point you are finding the gradient, you like this, so you would be finding the electric field, sorry, not the electric field, I'm really sorry, gravitational field strength or gravitational field intensity, although they are corresponding things in the two topics. Okay, so you would be finding the gravitational field intensity, or you can say gravitational acceleration at that point. So that will be because of the gradient, but we don't want it. We want to find the potential energy, sorry. Area under the curve r to 3r doesn't make any sense. That will give you, what is the area? It will be v into r. So v into r, I don't think it means anything. Okay, gravitational potential at 3r, that is correct. Difference in gravitational potential value. Now the difference between the gravitational potential value will be the change in potential energy if the body is going from 3r to r, or r to 3r. So you have to find, like, so this d will be giving you change in potential energy, but you don't want the change in potential energy, you want the potential energy in absolute terms. So C will be the correct answer. This is how we do this question. This is the explanation, dear students. Okay, dear students, thanks for watching the video. All the best. Bye.